Welcome back to Sumantra Codes. This is day 13 of our series, and today we are going to learn about errors and exceptions and how they differ and how to deal with them effectively in your code. Errors and exceptions are problems that occur when your code is executed. They prevent your code from running normally and may cause it to stop or crash. Errors and exceptions are different in terms of their causes and consequences. Errors are mistakes that you make in your code, such as typos, wrong syntax, wrong logic, etc. Errors can be detected before or during execution of your code. Errors can be fixed by correcting your code. However, exceptions are events that happen outside your control, such as user input, network issue, file operations, etc. Exceptions can only be detected during the execution of your code. Exceptions can be handled by using special code block that deal with them. Let's see an example. We are going to define a function that divides two numbers. Def divide x and y. Return x by y. Now we'll call the function with some arguments. Divide 10 by 2 and we'll print the result. Run it, and the function code has executed and returned the 5 value at the output console. However, when we divide this function with 0, this causes an exception, 0 division error, because you cannot divide a number by 0. This exception stops the execution of the code and print an error message like shown in the console below. Notice that the error message tells you the type of exception, 0 division error, the reason for the exception, division by 0, and the location of exception, which is line 3 in divide function and line 5 in main.py. This exception can be handled by using try except block, which we will learn later in the video. What are common types of errors and exceptions in Python? Let's see one by one. Python has many types of errors and exceptions that can occur when your code is executed. Some of the most common and useful ones are syntax error. This error occurs when your code has an invalid syntax, such as missing a colon, a parenthesis, a quotation mark, etc. We'll see an example. If x is greater than 10, print x is greater than 10. Now the editor is showing us the syntax error, and most of the modern editors show us a syntax error, and it's showing a tooltip which says :expected. When we run it, it will give a syntax error which is expected : The next type of error is name error. This error occurs when your code tries to use a name that is not defined, such as variable, a function, a class, etc. For example, if we print z and run it, this will cause name error like the one shown at the console, which is name z is not defined. Another type of error is type error. This error occurs when your code tries to perform an operation on an object of an incompatible type, such as adding a string and a number, calling a function with wrong numbers or types of arguments, etc. So over here, if we say hello plus 6 and we execute it, it will give type error like this: can only concatenate str, not int to str. Next type of error is value error. This error occurs when your code tries to use a value that is not suitable for a specific operation, such as converting a string to a number, indexing a list with a negative or out of range number, etc. Let's see an example. So we'll define a variable hello, which is a string variable, and if we try to convert it into integer and run it, it will give the value error like this, which says invalid literal for int with base 10. There are many other types of errors and exceptions in Python, such as index error, key error, file not found error, etc. You can find the complete list of errors and their descriptions in Python official document. So let's see how to read and understand error messages and tracebacks. When your code encounters an error or an exception, it will print an error message and a traceback on the screen. The error message and the traceback provide useful information that can help you identify and fix the problem. The error message tells you the type and the reason of the error or the exception. Let's go back to the first program where we defined a function that divides the two number. Now we again run it. So the error message tells you that the type of error is zero division error and the reason for exception is division by zero. The traceback tells you the location and the sequence of the error or the exception. The traceback consists of one or more line that shows the file name and the line number and the code snippets where the error or the exception occurred. The last line of the traceback is the error message. This traceback tells you that the exception occurred in the line 3 of the divide function, which was called in line 7 of the main code. The traceback also shows you the code snippets where the exception has occurred. To read and understand the error messages and tracebacks, you should follow these steps. Look at the error message and identify the type and the reason of the error or exception. Look at the traceback and identify the location and sequence of the error or the exception. Go to the source code and check the line or the code snippets where the error or the exception occurred. Try to find and fix the cause of the error or the exception by correcting your code or handling the exception. Sometimes you may want to handle an exception gracefully, which means that you want to prevent your code from stopping or crashing and instead do something else when an exception occurs. For example, you may want to display a friendly message, ask for a different input, or retry the operation, etc. To handle an exception gracefully, you need to use a try except block, which is a special code block that allows you to catch and handle exceptions. The syntax of using try except block is try, then the code that may cause an exception, except exception type as E, code that handles the exception. The try clause contains the code that may cause an exception. The except clause contains the code that handle the exception. The exception type is the type of the exception that you want to catch and handle. The E is a variable that holds the exception object that you can use to get more information about the exception. For example, let's use try except block to handle the zero division error exception that we saw in our earlier example. So after divide, we'll write try block and indent the return function, and to handle the exceptions, we'll write except zero division error as E colon, and over here we'll handle the zero division error exception. We'll print cannot divide by 0. We'll also print the exception object E. Now we run it and it is printing 5, cannot divide by 0, division by 0, none. Notice that we use try except block inside the divide function. The try clause contains the code that tries to divide x by y. The except clause contains the code that handles zero division error exception. We use the print function to display a friendly message and the exception object. We also use the return statement to send a value back from the function. When we call the function with 10 and 2 as an argument, the try clause executes normally and return 5 as the value of the function. When we call function with 10 and 0 as an argument, the try causes a zero division exception, which is caught and handled by except clause. The except clause print the message and the exception object and returns none as the value of the function call. The try except block allows us to handle the exception gracefully and prevent our code from stopping or crashing. You can use multiple except clauses to handle different kinds of exceptions. We'll modify this example a bit. We'll start by writing the try statement and inside the try block, we'll call input function, which will ask user to enter a number. We'll assign this number to a variable x and typecast it into an integer. Then we'll print 10 divided by x. Now we'll handle the different kind of exception. So over here, we can get an invalid input exception. So first we'll handle except value error as even, and we'll print invalid input. We'll also print the exception. Also, we can get divide by zero error exception, which is called as zero division error, as E2. And we'll handle this zero division error exception by printing cannot divide by 0. And we'll also print the exception object. This will allow us to handle value error exception if the user input is not a valid number. So we are running it. And if it's not a valid number, say II, it will give the invalid input text on the prompt and the program will exit gracefully. Similarly, if we enter number 0, it will handle divide by 0 exception by printing cannot divide by 0 and program will handle gracefully. You can also use generic except clause to handle any type of exception that is not specified. For example, try code that may cause an exception, except exception as E, code that handles the exception. This will catch and handle any type of exception that occurs in the try clause. However, you should be careful when using a generic except clause, as it can hide or ignore some important or specific exceptions. You should always use specific except clauses for the exceptions that you expect or want to handle, and use a generic except clause as a last resort. You can also use else and finally clause to execute some code after a try except block. The else clause is executed if no exception occur in the try clause, and the finally clause is executed no matter what, whether an exception occurs or not. Following is the syntax for using else and finally clause. So over here, else will execute when there are no exceptions. Finally contains the code that is executed no matter what. For example, let's use else and finally clauses to execute some code after the try except block that we used earlier. So this was the example. So we'll add else clause to print success, as we have not encountered any exception, and finally clause which print goodbye. This will execute else clause if no exception occurs in the try clause, and executes finally clause no matter what. For example, if the user input is 2, the output would be 5 success goodbye, because there is no exception that has occurred. But if the user input is 0, the divide by 0 exception, zero division error exception has been caught, and it has printed the message cannot divide by 0. Else clause code is not executed, but we have finally clause code get executed. So we'll see goodbye. The else and finally clause allow you to execute some code after a try except block, depending on whether an exception occur or not. Sometimes you may want to raise your own exceptions in your code, which means that you want to create and throw an exception deliberately. For example, you may want to raise an exception if your code encounters an invalid or unexpected situation, or if you want to enforce some rules or conditions in your code. To raise your own exception, you need to use the keyword raise, which is used to create and throw exception. The syntax for using the raise keyword is raise exception type message. The exception type is the type of exception that you want to raise. You can use any of the built-in or custom exceptions type. The message is the string that describes the reason for the exception. You can use any message that you want. Let's see an example where we'll raise our own exception in the code. So we'll define a function positive which checks whether the number which is passed as a parameter is positive or negative. So we'll say if not is instance x of int and float, which means that if x is not of an integer or float type, then we'll raise type error and we'll pass the message x must be a number. And then we'll check if x is less than or equal to 0. We'll assuming 0 is not positive. We'll raise value error with the message x must be positive. Now, if all the above conditions are not met, which means that x is a number and positive, and we'll return the x. Okay, now we'll print by calling positive with 10. I'll just copy paste it. Then I'm calling positive with -10, and then I'm calling with a non-number parameter which is high. I'm commenting this one, and if I run it, first it will print 10, and then when we have used -10, it is raising a value error exception where the text x must be positive. So we are over here adding message which is defining or describing the reason of the exception. Now, if I comment this one and uncomment the last one and print and run, I'll get 10, and I'll get the type error exception where the message x must be a number. The raise keyword allows you to raise your own exceptions in your code and control the flow of your code. So this concludes our session for today. We have learned about errors and exceptions. In the next episode, we'll learn about file handling in Python. If you have any questions or feedback, please let me know in the comments below. Thanks for tuning into Sumantra Codes. If you found this helpful, give it a thumbs up and subscribe for more coding tutorials. Hit the notification bell too, and let's continue this coding journey together. Stay tuned.